Okay, welcome back to chapter 4, which is measure of skewness. So what is measure of skewness? Is basically to see the spread of the data. Okay, so let's look at the learning outcomes for this chapter. We will learn the meaning of skewness, meaning what does skewness mean? What does the measure of skewness mean? How do you comment on the measure of skewness? There is a certain format. I'll teach you the format of commenting. And then we will learn how to comment based on the histogram, dot plot, stem and leaf and box plot. You will learn how to comment on these different kinds of diagram. Okay, using the commenting format here. Okay, all right. So let's look at this. So all this while we have been doing, right? Let's give you a minute. All right, so let's look at the shape of the distribution. All this while you've been doing, there is a spread to your data. All right, so now we're going to learn how to measure distribution. What is skewness? The shape of the distribution. Okay, your distribution normally has a shape. Why? Because maybe the concentration of the data, a lot of it is in the higher end like this, or the concentration of the data, a lot of it is in the lower end like this. Okay, so that is why you have measure of skewness. All right. Okay, so let's look at the types of shape that you have. So you have one that is symmetrical. So what is symmetrical? Meaning it is the left and right is equal. Okay, it looks symmetrical. All right. Asymmetrical meaning it is not symmetrical. Okay, so asymmetrical, there are two kinds. One is negatively skewed, which is skewed to the left, and one is positively skewed, which is skewed to the right. So basically we are going to be looking at this. Okay, so they are symmetrical. We'll go through the one by one. All right, so symmetrical distribution. So in your manual we are actually on page 106 here. All right, you may have to fill up the values here if anything is empty. 106, we are here. All right, so symmetrical, this is symmetrical. Okay, where the left and right, the distribution is equal, is approximately symmetrical. Okay, so now when it is symmetrical like this, your mean, median and mode is equal, which sits in the middle. What is median? The middle of the data, isn't it? What is mode? The one that repeats the most. Do you see the highest peak? That is your mode. And mean is the average. That is why you call mean, median and mode the measurement of central tendency. Remember, I taught you mean, mode, median, and I called it MCT, measurement of central tendency, because the mean, mode, median sits right in the middle. Okay, sits right in the middle here. So whenever your distribution is like this, it looks quite symmetrical. You will call it the distribution is somewhat, almost. You cannot say it's exactly symmetrical. You can only say it's exactly symmetrical when you have values. When your mean, median and mode value is equal, then you know it's exactly symmetrical. When you don't have values and you're just commenting on the shape of the distribution, you can only say somewhat, almost or nearly. You cannot go and say it is symmetrical. All right, so when your mean, mode, median is equal, it is somewhat, almost, nearly or roughly symmetrical. Okay, all right. Okay, so this is your symmetrical distribution, or in other words, when we learn it later on in chapter 5, you will learn this as normal distribution. So whenever somebody says normal distribution, why does it look like this? Okay, why do we call it normal distribution? Because it is what normally happens in the world. So now if I collect data from about maybe 500 people, the heights of 500 people, I will get a curve that looks like this. Why? Because there will be a small number of people who are very short, there will be a small number of people who are very tall, and most of them fall in the average height in the middle. Do you see that? Most of the people will fall in the average height here. A very small number will be very short. A very small number will be very tall. This is actually just the number line, numbers from big to small. Okay, so that is why the symmetrical distribution is also known as normal distribution. Why is it known as normal? It's because it's the norm. That's what happens. Exam results also same thing. Okay, the exam result usually whenever it's a fair paper or it's a fair population we collected data from, your exam marks will look like this. If it's not like this, we will make it to look like this. This is what you call modeling the data or adjusting the marks. Why do, like SPM and so on, why do they adjust the marks? Because they opt for a normal distribution curve. Why do you opt for that? You have a small number of students who have failed, a small number of students who have done really well, and most of them should fall in the middle. Okay, so this is what you call adjustment of marks. This always happens because this is your aim. You collect any data, this is your last aim. You want it to be symmetrical, you want it to be a normal distribution. Okay, so let's look at what happens when it's not normal distribution, when it's not symmetrical. It can happen, and why does it happen? I'll tell you why does it happen later. So let's look at the type of spread. Skewness means the shape of the distribution. So when it is not symmetrical, you have asymmetrical. There's two kinds, all right? One looks like this. What does this tell you? If this is exam results, what does this shape tell you? Most of the students did very, very well. So very, very well means it's either the paper was very easy, okay, or it's either the students got the questions beforehand, something like that. Okay, so most of the students did very, very well. So this, the shape of the distribution here tells you most of your data is in the higher end. So what do we call this kind of distribution? So there are two words for it. Okay, you can call this negatively skewed. Why negatively skewed? Why do we use the word negative? Because if you want to correct this data, for an example, if this is exam results, all right, if this is exam results and I need to correct this, I need to adjust the marks because I can't have so many students doing so well, all right? So what do? We reduce the marks. Correct? We reduce the marks. That means we increase the pass marks, we increase the marks. So we reduce the marks, we adjust it, reduce the marks. You reduce the value of the data. Therefore, this is what you call negatively skewed. Okay? Another word is skewed to the left. Why skewed to the left? Because you want to move the data to the left. That's how you correct it. All right? So in this case, your mean is smaller than your median is smaller than your mode. Okay? Why is your mean smaller than your median? Because your extreme data lies here. This is where most of your data is, right? This is where the concentration of data is here. So your extreme data is in the smaller end. Therefore, your mean is smaller than your median, smaller than your mode. Okay? So let's look at the format of commenting. First point, you want to use left and right or you want to use negative and positive is up to you. So skewed to the left or right. So in this case, it is skewed to the left, or you want to write negatively skewed, okay, where 75% of the data is from Q1 to maximum. I will show you why we use Q1 and maximum. That is the standard way of commenting. Okay, I'll show you why later. Okay, all right. The next one would be positively skewed. So if this is exam results, what does that tell me? Most of my students did so badly. Okay, because most of the data is in the smaller end. That means most of my data is very small. Okay, so what does that tell me? Maybe the exam paper was too difficult, or maybe the students didn't study or something like that. Okay, so this is what we call positive skew. Why positive skew? In order to correct this skewness, in order to make it symmetrical, I need to increase my data. So it's positively skewed, or you can say skewed to the right. Why? I need to move it to the right, isn't it? Then only the curve will look like this. That is my aim. So you call it positively skewed or skewed to the right. You can choose which one you want. You want to use right or positive, is up to you. 75% of the data is from minimum to Q3. Okay, so I will tell you why we use minimum Q1, Q2. This is how it looks like actually. When you want to draw a curve above a box plot, it looks like that. The minimum value, then the curve will start to rise when the box starts and it comes down when the box ends. So what does this tell you? 75% of my data is from minimum to Q3. This one, you see when you draw, goes and it starts to rise when the box starts, go down. So this one, my data, 75% is from Q1 to maximum. That is how you look at it. All right. So I want you to comment this way. You can comment in point form, no problem. You can straight away write negative skew, skew to the left. Next point, 75% of the data is from here and here. No problem. You don't need to write it as a whole sentence. Okay, so now let's look at why does this happen. Okay, you don't need to memorize this theory. It's just for your own information. Sometimes it can come out, sometimes no. Okay. Okay, so one of the reasons would be insufficient sample size. For instance, right, if I want to take results, your maths results, I take about 8 students and I collect. Of course, my data is not, I don't have a big sample size. I need a big sample size in order for me to see the shape of the distribution. If I just take a small sample size, it's not going to show me the right shape. It might be skewed like this, because maybe all of them did very well. Most of them did very well. Or it might be like this. Most of them did very badly. Okay, presence of outliers. You see, like here, there might be presence of outlier here. Maybe the small value here is an extreme value, that's why. Or the big value here is an extreme value. Okay, no healthy mix of population. That means if let's say I'm taking heights and I get a bunch of students who are all very, very tall. Of course, it will look like this, right? Or if I'm taking weight, I get a bunch of students who are very, very light. Then of course it will look like this, right? Okay, so this is what healthy mix of population means. Reflects the distribution of the 75% of the data where the response is biased. Okay, you can actually see where is 75% of your data. In this case, I can see 75% of my data is between Q1 to maximum. Here, 75% of my data is from minimum to Q3. All right, so you can just read through this. This is actually just repetition. Okay, so commenting on skewness, again, I want 2 points. Skewed to the left or right, or you want to use positive or negative, is up to you. 75% of the data from where to where. Use the format from here. You cannot use any other format, all right? Don't go and put it in your own words. Okay, so this is actually in your manual. Right now, we are actually on page 108. So you're going to comment for me. They've given you the 5-number summary, all right? They've given you the 5-number summary here. All you need to do is just comment. So you draw a curve and you see, oh, distribution is negatively skewed or skewed to the left. All right, why? Because most of your data is here. You want to correct it, you need to move it to the left. You want to correct your data, you need to reduce the value. Therefore, you call it negatively skewed. Where 75% of the data scored from Q1 to maximum, Q1 to maximum, 55 to 100. Same goes to this. This will be positively skewed or skewed to the right. 75% of the data is from minimum, 10 to Q3, 60. Standard comment, please make sure you use the same comment. Okay, the next one would be a dot plot. So they have given you the dot plot. You need to find your 5-number summary from the dot plot. A lot of students, by the time they reach here, they always forget how to find 5-number summary. You please go back, refer how to find. Okay, so your minimum is 2, maximum is 7. How to find Q1? You count the total number of dots. 1, 2, 3. You count how many dots in total. N plus 1 times 1 over 4. You will get the position of your Q1. Then you count. Where is your position of your Q1? Okay, so here I've actually given you the values. All right, I've given you the values here. Just, I know this is number of siblings. It's okay, just leave it as decimal, no problem. Okay, so you will get that basically your Q1 will be 5.5. So between the, 5.25, between the 5th and the 6th data. So the 5th data is here, the 6th data is here. So 2 and 3, you add up, you'll get 2.5. Okay, so please go back and revise if you don't know how to calculate. That's why I'm saying statistics for semester 2 is very, very, each chapter to another is very connected to one another. So it's very repetitive. You must know how to calculate. So you find Q1, Q2, Q3 for me and you comment on the distribution. Same goes to the next dot plot, which is here. Okay, then same thing here, stem and leaf. I want you to calculate, find your Q1, Q2, Q3, find your 5-number summary. The answers are already in the slides. A lot of you are asking me where are the answers. The answers are already in the slides on MS Teams. Okay, So find your 5-number summary. You can check here. You can leave this as a decimal, no problem. Okay. And this one, just be careful. You can rearrange it because here it's from big to small. This is the right format. So rearrange it and comment accordingly. All right. So this is the box plot given to you already. The values are there. So it's quite simple. All right. So now here you are basically going to do exercise 4.1. They have given you an ungrouped data. Least and greatest number, you're going to find the smallest and the biggest value. Find the median, Q1, and upper and lower quartile is Q1 and Q3. Then you draw the box plot and comment on the shape. Okay, comment on the shape, the 2 points that I just taught you. Other observations that you can see would be all, what would be additional? The housewife spends between 14 to 43 minutes shopping. Okay, you can even say that half of them spend 24 minutes on shopping. Is up to you. Okay. Question 2, you're supposed to draw a dot plot. So you should be able to draw it now. You would have just done revision for your exam. Okay. All right, so you draw the dot plot, find the 5-number summary. What have they asked you here? Comment on the shape. So you comment on the shape of the distribution. Additional observation, you can just refer to my slides. You don't worry, you will not see this in your exams. It's just to show you what else can the box plot show you. That's all. Okay, then you have question 3 here. Okay, they've given you this. They want you to just draw the histogram. I understand all this while you have been doing histogram. You use intervals, right? This is just a little bit different. So you find your median. If you want to find all this, what you need to do? You need to add an extra column here called cumulative frequency. See, I've put it here for you. You use cumulative frequency, find your median, Q1, Q3, find your IQR. Okay? Then that's your 5-number summary there. You just draw the histogram. It's like a standard bar chart, but just make sure it's connected to one another. Just draw it like that, no problem. Comment and give the additional observations that you can see. See, simple things. The range is 0 to 7. You write 1 or 2 enough already. Okay, only one student was absent for 7 times. Something like this. Or you can say the most students were absent twice. So whatever you can see from here. All right. Okay. Okay, exercise 4.2. So this, they have given you here a dot plot. So what is the minimum and maximum shown? So what is happening here? It's a 2-sided dice that you are going to basically roll. Okay, so the minimum in this question is 2, the maximum is 10. Okay, what is the minimum and maximum sum possible for this trial? Possible means what it could have been. This is the experiment value. That means in the experiment, the minimum was 2 and the maximum was 10. The minimum is obviously 2 because you're rolling 2 dice, right? Both the dice come out 1, 1, that would be the minimum. Okay, what would be the possible maximum? 12, right? 6, 6. If both the dice I get 6 and 6, it will be 12. It is just that in this experiment, they never got 6 and 6. So the sum possible will be 2 and 12. Okay, so here you need to draw the box plot. I want you to calculate your 5-number summary accordingly. Okay, your minimum will be 2, maximum will be 10. Find your Q1, Q2, Q3. Draw and comment on the shape. So you can refer back to the slides here. So when you look at this shape, this would be approximately symmetrical or nearly symmetrical. All right. That's it would do. You don't need to add on these 2 things. All right. Okay, next one. Find the mean weight. So when you want to find mean weight, what do you need to find for me? Your midpoint, FXI, and then you find your mean weight. Okay. So here they've given you an ogive. The percentage is shown above. Use this graph to estimate the value of the median. So it's just an estimate. Median will be 50%. You come down, just estimate. Okay. According to the packing standards, 80% of the eggs packed should be between 43 and 63 grams. So I want you to use, so 80% are between 60 and 65. So it did not meet the standards. All right. Moving on, you'll be doing, you don't worry so much. In your exam, you won't get something like this. In your exam, will be very accurate. You will be able to read it. Okay, I know this one you cannot read. So you just estimate. Estimate the median, 50% come down. You just estimate some value that is between that two. So in this case, it doesn't need to be so close to mine also enough. Some of you write 3, 4, no problem. Okay. Estimate of a quarter of newborns to be under. Quarter is what? 1/4, 25% come down. All right. What percentage would you estimate to be under 3.7 kg? So 3.7 kg is here. Under 3.7 kg, about 69%. You try to just estimate lah. Between which two weights the middle lies? So your middle 50% is between what? 3,000 and 3,500. So you need your 5-number summary. I totally understand you cannot read exactly. I have no issues. Just use my values here. Use the values that I found. You don't worry. Your exams are repeating this again. You will get an accurate graph where you can read it accurately. Okay, so for today's class, we will just do question 1, 2, and 3. Okay, I will go through for the rest of the questions as well. It's just for your next class. Okay, so question 4 is the same. You have ungrouped data. You just calculate the mean. You find the standard deviation, and that's about it. Okay, question 5. How many students sat for the test? You're going to give me your N. Find your IQR using the stem and leaf. The minimum score may be an outlier. Verify this. How do you verify an outlier? There's only one way. You find your lower boundary. This is minimum score. So they're saying that the smallest one is it may be an outlier. So because they're saying minimum score, you just find your lower boundary and check whether it's an outlier or not. Okay. So remove the outlier and draw the box plot. Okay, so there is no outlier, so there is nothing to remove. Don't worry, no outlier, no need to worry. Okay, then you just draw the box plot as usual. Next one. Produce a stem and leaf with an appropriate stem size to display this data. So this is how the stem and leaf will look like. 12, 13, 14, you just separate the decimal point meaning. Okay, make sure you write your key. Find the mean, find the standard deviation, find the 5-number summary and draw the box plot. Okay. Question 7, calculate the mean estimated weight. So you calculate the mean, then they just asked you for the proportion. Proportion is always percentage. Underestimated the width of the room. What is the width of the room? 6 meters. Underestimated mean they are saying it is smaller than it is. So how many students measured less than 6 meters? These two, right? 4 and 5, right? So 3. So 3, I'll show you the working here. If it's here, yeah. 3 out of 15 times 100%, 20 students. How many students overestimated? Meaning they are saying is bigger than 6. Okay. All right. So these are the total number of students. 7 out of 15. So let's take a look. It will be this part here. 7 out of 15. Times 100%, you'll get 46.67%. Percentage, always 2 decimal places unless the questions specify otherwise. All right. Question 8, you're just going to find median. Again here, you got to estimate. There is no choice. You got to estimate. All right. Okay, what is the median bill? 50%. Come down, just estimate it. You will see it as 45. Okay, what bill amount do only 5% with those with mobile phones exceed? So 5% of students, those with mobile phone exceed. Actually, you can skip part B. Don't need to do part B. All right, calculate the IQR. I would rather you just use my values. Or if you cannot, if you don't want, you can just estimate. Make sure you get close to my values. Normally, we accept a range if it's this kind of graphs. Okay, if there were 80 students in this group, how many paid over 40 that month? Over 40 is here, right? More than 40. Who paid? How many percent paid? 60%, right? Because 40% paid less than 40. So 60% paid more than 40. So you will have 60% of the students who paid more than 40. So you find that 60%, it would be 48 students. All right. Okay, what type of variable is involved here? Basically, this is discrete data. Why is it discrete? It's a whole number. Okay, it's a whole number measured to the nearest knot. So prepare a histogram using an appropriate interval. What I would do is just use my intervals here. Normally in your exam, they won't ask you to find your own interval. So you don't worry. Copy my intervals here. Okay, come up with the midpoint, come up with the frequency because you need to calculate mean later. And you will need your cumulative frequency. Why? Because you need to find your Q1, Q2, Q3. Okay, so just use my intervals and come up with the histogram. All right. Estimate the mean. When they ask you to estimate, you cannot use your formula. You could estimate from your histogram, crisscross and come down. Okay. Any outliers exist? Use your lower boundary, upper boundary and find got any outlier or not. Okay, yes, there is an outlier which is 34. How you know 34 is an outlier? Because you have the ungrouped data here. So you just see which is an outlier, okay? See, the from 30 to 35 frequency only one, which is only one data, which was 34. What proportion of the wind speeds were 20 knots or more? 20 knots or more means this part. That means 8 out of 40 times 100%, which is 20%. Okay, now they ask you to comment on the shape of the distribution with the outlier. If you look at this, it is positively skewed, where 75%, make sure you complete the whole comment, percent of the data lies within what and what. Okay, the last question here, number 10. What are they asking you? The minimum and maximum number of concerts attended. Minimum is 0, maximum is 8. Find your median, lower quartile, upper quartile. Please add your cumulative frequency and find it and draw your box plot. Okay, so now I will show you. This is the original box plot where your minimum is 0, 2, 3, 4 and 8. So your minimum is 0, Q1 is 2, Q2 is 3, Q3 originally was 4 from your original box plot. So when you're doing this question, pause and play. Draw this box plot first, then come and join me for this last part of the question. If not, you won't understand what's going on. A new student joins the class. He had attended total of X concerts during the past 12 months. The box plot drawn below includes the results of all 21 students. Meaning now there's one new student has joined. Okay, so the frequency may go anywhere, can go anywhere inside here. How do you know where? That is what they are asking you. What would be the possible values? Where would what would be the number of concerts that he would have attended? Could it have been 0? Could it have been 2? Could it have been 3? Could it have been 4? Could it have been 5? So you're not sure, right? So let's look at the original box plot. The only difference now is at Q3. Original Q3 is 4. The Q3 in your box plot is 4.5. Correct or not? 4.5. So what is the difference? Is at Q3, right? So you first of all need to find your Q3 position. Originally your Q3 was here. Correct or not? If that boy attended only 4 concerts, the Q3 won't change. It will still be 4. It will still be 4. If that student, let's say the student attended 0 or the student attended 1, 2 or 3 or 4. The Q3 would have either been lesser or it would have still been 4. Actually, it would have still been 4. The only possible values for the Q3 to change from 4 to 4.5 would be if he attended 5, 6 or 7 concerts. Okay, 5, 6 or 7 concerts would have been the possible reason why your Q3 changed from 4 to 4.5. All right, okay, so that's about it for chapter 4. It's pretty much a very short chapter. There is nothing much to it. So today, in today's class, we have completed chapter 4 basically. All right, so it shouldn't really, I really hope you'll be able to manage it. Okay, any questions, please ask. This chapter always comes out. You draw your box plot and comment. It always comes together as a package. All right, so any questions, please do reach out to me. For now, we will stop here. So for today, we will do page 108 to page 115. Okay, which is until question 3 of exercise 4.2. The other questions from exercise 4.2, we will continue in the next class. All right. Okay, so Any questions, please do reach out.